This is Mechanism Tutorials, part fission reactor and turbine, take 4. In this video, we are going to be talking about the fission reactor and turbine. Throughout this video, when I say reactor, I mean the fission reactor. So, particularly what we're going to be going over in this video is the fissile fuel to fuel the reactor, how to build the reactor, some warnings about the reactor, the coolants and how it works, along with the byproducts. Then we will be going over the turbine with how to build it, how it works, and lastly, we're going to be talking about the boiler. I will put, this is your very first warning about the fission reactor. It will explode, has a chance to explode, if not maintained properly. So, first thing I can give you tip-wise right now, if you are worried about this blowing up your base, do not put this right in your base. Typically put it somewhere where you can still get to it quickly if the chance occurs that it's going critical. So let's jump into fissile fuel. What is fissile fuel? Fissile fuel is how you fuel your reactor, and it's what is getting burned to power the reactor. The way you create fissile fuel is a big line of production. So, pretty much, you are starting it out with sulfur dioxide. How you get sulfur dioxide is by throwing sulfur in a chemical oxidizer to create sulfur dioxide. Now, there is 4 sulfurs that you can do this with. You can do this with the Mekanism. You can do this with the thermal series sulfur. You can do it with blood magic sulfur or create. The way I'm doing it is through the thermal series, which is putting either a block of coal or coal itself into a pressurized reaction chamber. Mix it using oxygen and water, you will then get sulfur. Now, the way I'm doing this is by having, well, I'm using an infinite water tank here, but you're going to use electric pumps. Pumping the water out into electrolytic separator, which you might have done this earlier, and will have oxygen to use when you're making gas earlier. I'll flash up on screen the gas. So you'll have oxygen already going, because you will have had it set to dumping, access, or just dumping. So now what you're doing is you're taking the sulfur dust, if you're doing it this way, and then turning it into the sulfur dioxide. Now, I will go ahead and mention, because I just skipped over this, when you're doing this situation, you are actually creating more hydrogen. Now, you can either use this hydrogen in other productions, or throw it in a dynamic tank for storage for later use. Now then, you're going to be taking this sulfur dioxide and making sulfur trioxide. Now, to make sulfur trioxide, you are going to be throwing it through a chemical infuser. You're going to be combining the sulfur dioxide with oxygen. So, another thing to use oxygen. So, you might want to separate things specifically for this production, if you decide to go the path that I went. So, making the sulfur trioxide, you're then going to throw this into another chemical infuser, combining it with water vapor to get sulfuric acid. Now, to get water vapor, you're throwing water into a rotary condenser to turn it into gas instead. and then pumping it into your chemical infuser. Now you're going to take that sulfur trioxide and throw it into the sulfur acid, my bad, and throw it into a chemical dissolution chamber with some fluoride. Now, again, I'm using Project E for this section. There are other ways of gathering fluoride, either through laser drill. I'll probably have a separate edit here right now talking about other ways of getting fluoride. But you're going to be putting fluoride in with the sulfuric acid to get hydrofluoric acid. At this point, you will be combining that hydrofluoric acid with some uranium oxide. To get uranium oxide, you need to throw a yellow cake uranium into the chemical oxidizer. To get yellow cake uranium, either EMC, if you went that path first with Project E and then come back to this, or doing uranium in through a enrichment chamber or elite enriching factory. So you're combining those two into your uranium hexafluoride, which then you'll throw into isotopic centrifuge to make your fissile fuel. Now we're storing it because I just wanted to store it and have extra left over. Now that we have talked about that, let's mark this off and we're going to talk about how to build a fission reactor. A fission reactor can be built as small as a 3 by 3 by 4, which we will build real quick, and as big as 18 by 18 by 18. Now I just did the 17 by 17 by 17, but you can go as big as 18 by 18 by 18. So here's how the small. Okay, so I'm going to, as I just mentioned, the biggest you can go is 18 by 18 by 18. Now, do you want to build a 3 by 3 by 4? No. If you are new to this mod and you want to play it as safe as possible and you're only doing it for power, then go ahead. But if you are trying to move further into the path and get to the world card, you would need to build bigger. I would recommend building between a 5 by 5 by 5 or 10 by 10 by 10. Now you can go as big as I did if you're producing enough fuel for it. Now here's where some more warnings are coming. Well, let me build and then I will get to warnings. So here I'm gonna build a 5 by 5 by 5. So there's 5. There's 5. What? No, we're going to build a 7 by 7. We're going to go to the middle ground. Okay, there's 6. And then there's 7. Now you're going to go up 7. Okay, 7. Go over. Now I won't have this fill into that one because that turbine is for the big boy. You kind of want to build around the same height or build between the two. Alright, so here's the frame. Now here is where you can technically differ. Creating fission reactor casings is a little expensive. So what I actually do recommend is doing the inner part of the frame out of reactor glass because it is so inexpensive. So we're going to go ahead and do that. Now, I'm not going to fill the glass in. Well, actually, I will fill the glass in using our handy dandy wand. There we go. Now we got to fill this inner part in. So you're going to want to make some fission fuel assemblies and some control rod assemblies. Now, when you're building this part, you have to have it checkered. Well, I think it has to be checkered. I've never built it where they're right next to each other. I do it this way because this is how I learned how to do it. Alright. So, this last layer, you're going to want to throw on the control rod assemblies. There we go. Now we can fill this top layer with glass. Whoop. And there we go. Technically, it is done. It didn't give us the red particles. It did now. Sometimes you might have to do that. Okay. So, here's what we did not add. I have in my list. Okay? To go over the industrial alarm, the fission reactor logic adapter, and the fission reactor port. With the fission reactor port, you're going to want 4 of these. So I'm going to put one there, and then I'm going to put one here. Now, make sure you have your configurator on. One of these you're going to want for waste output. The other you're going to want for coolant. Now, take your radioactive waste bin, some pressure tubes, and some mechanical, because I didn't have that in that chest. Take the radioactive waste bin and put it here. This is so that if you don't go into the next part for the byproducts, you're pumping it out. The coolant, we're going to just put some pipes there for now, because this is where your steam is going to be. And then your inputs. So let's grab the fissile fuel tank and start having that pump in. Okay? Now here's where the water is. We're go ahead and get water going in, but we'll be coming back to this. Okay. So go and get water pumping. Now the logic adapter. How the logic adapter works, as most people will probably use this for, is an early warning. Is a warning system. Now you can also use it for a lever. So I probably should not have done the set it up to fill fuel yet, but it's a little too late for that. But how these work is that when it's completed, you'll right click on each of these and set to different thing. I recommend highly to have all of these set to one of these different actions. The activation is only for activating and deactivating your reactor quickly, as such. Okay. On these though, do one of two things. You can either have it set to where these will be put on, and when these activate, any one of these activate, it'll activate activate one of the alarms. I recommend getting some redstone links from Create and throwing them on instead. And setting it to having these in frequency 1, having them go out. Because when you do this, these actually send out redstone signal. And when these get activated, you'll hear that alarm. That alarm is your indicator that something is wrong with the reactor. Shut it off. Okay? So, I would recommend putting these anywhere around your base that you will hear it. So if you have a mega base, put a lot around. That way you know that, hey, something's going on with your reactor, get to it. So that is how the reactor is built. So we're going to go ahead and mark that off. Let's mark that off. Okay, so I will get to the warnings in a bit. Now then, there are two coolants for the fission reactor. There is, as you can see here, water. The other is sodium. When we get to the boiler, I will talk more about sodium. For new players, I recommend highly to do water. Okay? Now, what I mean by new player, like this is your first or second time doing this. Especially first. If this is your first time doing a reactor, a fission reactor, do not go crazy with it. Go simple. And then, once you are confident that you have enough production of fuel to go with one of the bigger reactors, then go with bigger reactor. Like I said, your sweet spot as a new person, like this is your first time doing this, don't go above the 10 by 10 by 10. Now, can you make this rectangular? Yes. So you can technically, if you want to, do a 5 by 5 by 18 if you want to. Okay, we're going to go into some warnings about the fission reactor. My first warning is your fissile fuel production. As you can see over here, I have 2 of each machine going. Planning out your fissile fuel production first is always a good idea. Because when you start messing around with the reactor itself, you want to make sure that you have enough fuel being produced that it's going up instead of down. Because I found out as I was pushing the burn rate up to where I could push it for a water-cooled reactor, that I had to find that sweet spot where fuel wasn't getting burned too quick, but it was still getting made quick enough that I could push that burn rate. The next is that, as I have mentioned already, the fission reactor can blow up. This is the only structure I am aware of in Mekanism to blow up. If a fission reactor blows up, it's not good. Radiation does go all over the place, and you have to wait a bit for it to clear out. So, when you are, if it's your first time doing a reactor, when you get it up and running the first time, make sure you have a hazmat. If you get enough byproduct made, which we'll go over the byproduct, you can make something else, which again we'll go over towards the end. My other good tip is that don't push the reactor too far. There is a threshold that you can do that is a safe point, which I will show you when we get this one up and going. There's a few more warnings that I will give afterward, but we're going to work on how to build a turbine. So let's grab everything for a turbine. put everything else back in. That water could go in there. That all this can go in. Just put that there. Now for the turbine. The turbine has more parts than any of the other structures. You need a turbine casing, which is actually kind of simple to make, a turbine vent, a rotational complex, advanced circuits, one set of turbine valves, a saturated condenser, a pressure disperser, electromagnetic coils, turbine blades, and turbine rotors. Now, I have structured glass on the end of this. This is not as costly of a build materials wise. The thing is though, if you're like me and like seeing things that move around in this mod for the multi-block structures, definitely go with the structured glass. And I'll show you. But let's get this built. So, when you're building a turbine reactor, this is the one structure that it has to be a rectangle. It cannot be a perfect cube. Well, I take that back. It does not actually have to be, unless you're going for the max size. So, the smallest that you can make a turbine is 5 by 5 by 4. I would go 5 by 5 by 5. The biggest is 17 by 17 by 18. What's with the odd number width and length? It's because you have to have the rotor dead center of the build. So you can't do an even width and length. You have to have it odd. So let's get to building this. We're going to build a 7 by 7 by 7. So 1, 2, 3, 4, 5, 6, 7. Go out. 1, 2, 3, 4, 5, 6. Build it this way. There's 7. So, some things to go ahead and note. What is turbine's purpose in this build? The turbine is what it is making the energy itself. Actually, no, I'll build this way I've normally built it. I was gonna test it with glass, but this is one of those things that we're gonna test something like that now. When I restart playing this again, an actual playthrough, I will go over when I play this through again, I will go over some of the things that I would normally do, and we'll probably test out then. Okay. Now, with this being the part of the reactor that generates power, we're setting up as such. So I'm going to set this up with 3. Now, I will say this. There's a lot of math that is involved with this, and between this, the reactor, and when we get to the boiler, there's a lot of math that is going on with this, with all this. I do not know the math. I have watch videos for this stuff, they know the math. I do not. My math skills only go so far. And this pushes it. Okay. So, let me go back to explaining. So, after you have put down your rotational complex, usually how the rotational complex will work is that you're pretty much player height with this. So, the roof needs to be the turbine vents, which I didn't even need to do that many. Let me go ahead and fill that with glass. Next to, on the layer with the rotational complex will be dispersers. The pressure dispersers. I'm going to leave enough room for me to get out. You can do the one with this, but because it's a small one, I'm just hand building it. I'm going to do that for a moment. The layer above that has electromagnetic coils in it. These have to connect. So if you decide to do like 7 of them, you need to make sure that they all connect. They can't just go like that. They have to connect. But we're going to go with 3. Next to the electric coils is saturated condensers. And then above that is the vents. Which I did mess that part up a little bit, but we can easily get that refixed for the vents. Okay. Fill that in. Fill that in. Now, technically this will complete, but it's not actually complete. You gotta put the vents. Most people will recommend that you do this, have 2 layers like this. I even highly recommend it. But something that some people do, some people don't, is place pipes around this outside layer. Okay, that's complete. You need to put the valves in. So you need 2 valves for this. One's gonna be for energy. One's gonna be for the steam. Now, what I do, I fill this entire layer right here with mechanical pipes. Why is that? I like to have a buffer of water. These vents will actually fill with water, and this is how you get your water back. So I make sure that every single vent that I have has a pipe connected to it. Okay, those pipes are connected. Now what I do, I connect these pipes back over to the reactor and make sure it goes into the inlet. So as we finish some things up and talk about some other things, we'll let that fill up. Okay. Now, even though I know how to deal with this, I am going to put on a hazmat suit. Of course that would happen. A hazmat suit. We'll take a look to see how to make this. It's relatively easy. Okay, I'll put this on. Anytime you are doing anything with the fission reactor, you kind of want to have your hazmat suit on. Okay, our water buffer is set up. We're going to make sure we get pull the energy out of this. So I'm actually going to grab one of these, grab this, and I'm going to just throw it into here. Because more than likely I'll have all this run, like all 3 reactors running for the next video. Okay, so here is the entirety of how this works. I'm going to drop some stuff real quick. Drop that. Drop that. Nope, don't pick any of it up. Okay. Now let's go over how this works. So, assuming that you have put all this together, you're running water as your coolant. You have built your reactor. You have gotten your turbine built. You have your alarm set up around your base to let you know if your reactor is starting to go critical or something else is wrong, or you're out of fuel. Let's get started. Alright. So, I'm going to push this real quick. What? I'm not going to worry about the small one, but this is how you put it all together. Let's go over to this bigger one. Okay. So, how this actually works, and I need to drop the rate of this back down. Usually when you first look into this screen, it will usually be on a 0.1 millibucket tick rate. Now, the reason why I say don't bother building the smallest fission reactor is because the max burn rate is only 1 bucket. And, well, 1 bucket, if you go back here to the waste, it's producing no waste. Well, it's producing waste, but not enough that you can use. How the waste works is that when it goes into the barrels, it gets used up. So these are actually slowly... Okay, this one's going up. Okay. But the rest of these aren't. Only the one's filling up. And if you're running the smallest one, which I've checked it out, it's only producing enough that it will eventually go away at the same time. So, I'm going to go ahead and pump this up real quick to about 50 so we can see some things going on. Okay. So what's going on is it is burning the fissile fuel. It is turning that water into steam. So as the fissile fuel is being burned, it is being produced into nuclear waste. The water is getting turned into steam, which is going through the pipe and going into the turbine. The turbine is rotating, which is producing your energy. As it's producing that energy, it is pushing it out into your induction matrix. Now, what's going on with that leftovers? That steam. Well, that steam is actually being turned back into water, which is then filling back into your reactor. So you're pretty much have created a cycle. You're creating fuel to burn, to turn into steam, to burn, turn into waste for the byproducts. You're turning that water into steam that will then turn the steam into your energy, which is going back into water, back into the reactor to go back into the turbine. Now, if you wanted to, you could technically put this to dumping access. Problem is, you don't get your water back. Never set your thing to dump. You don't get water back. Now, if you are running this for the first time, I bumped this up to 50. I just saw I had it at 300. Your first time around, when you build a reactor, only do increments of 5. If you get to the point where you're still making so much more fuel than you're using, then you can technically bump up the increments to like 10 to 20. Just don't go overboard. The reason is, and I'll just bump this up to 300. The reason is that if you bump up your amount too quick, you will go through your water almost like that. So you have to make sure that when you do bump it up, that you're keeping an eye on your water and that it is sustained. Okay? And you keep an eye on your temperature. If this goes above 1,000, which we're going to push that real quick, I'm going to say it's at 300, 350. I guess let's go a little bit more. Let's push it. We're going to do 360. 375. At some point, this will no longer, you cannot push it any higher. Once it reaches the temperature of, I think, 1.2, pushing it. Okay. I believe it's 1.2. We're gonna get it to dangerous here. Increments of 5. Okay. Okay. Oh. Future patient here. On quick editor's note, I was about to go into testing this, but I decided not to. Pretty much, if you are running these two big boys, you want to have a efficient enough way to pulling power out of the turbine. Because what happened was the water just dropped where there was nothing, and the reactor started taking damage. That was because I had this maxed out on power, and only one port or one valve extracting that power. Because of that, this was getting enough power to it. This filled up, which took the rest of the steam, which took all the water, which then caused this to take damage. If you do not have that efficient way of pulling the power out, or enough to pull the power out into whatever storage you're running for power, then you will cause your reactor to blow up and cause radiation to go all over the place. So keep that in mind when you are running these machines. Sure. Well, actually, no. We're going to move on to the byproduct real quick. The byproduct of this, as you saw, is the nuclear waste. There is 3 things you can do with this nuclear waste. You can throw it through a solar neutron activator, which will then turn it into polonium. Polonium is used for 2 things in this. 1, to make polonium pellets, which you use to make a whole bunch of things, from like the modification station, your QIO drive, which we'll go on that in a different video. It's not of importance. And then making your mecha gear and other things that are involved. The other thing is keeping it as the, and here's how you make the pellets. You throw it into a pressurized reactor chamber with some fluorite dust, and you'll get the pellet along with spent nuclear waste. Pretty much you're going to extract this, and you are going to throw it into more barrels and let deteriorate. The other use for polonium is going through the critical phase shifter and making antimatter. We'll go over that in the next video. The other thing you can do with this is make polonium pellets, which is used to make the SPS casing, which is for the phase shifter. The other thing that you do with this is hold on, should be some of the salt. Give me a sec. Yep, here it is. You throw the polonium pellet with either salt or hydrochloride to get repossessed fissile fragments, which is used to continue moving forward. Okay, with that having been said, let's move on to the boiler. The boiler is a completely different setup from the one that back there. This one is a little bit more in depth. This is using sodium as your coolant. There are two coolants, water and sodium. If you decide to go sodium, and this is where, if you are wanting to push more energy and fuel, this is what you do. Because it's not important and it can cause other problems and lead to even bigger issues to having your place blown up. But here is how the boiler looks and is built. Like I mentioned, there is a lot of math going on into this that I don't know how to explain. I just built it the way someone else built it in the video. But what's going on is you have a layer of your superheating element. You then can have a layer of water. I have two here. Then you have a layer right here is a layer of the pressure dispersers. This upper layer is a steam cavity for extra steam. At this point, it kind of works in the same way as the normal fission reactor and turbine alone. Is you activate it. We're gonna get this up a little bit more, and then pretty much what it's doing is it's superheating the sodium, which is going into the boiler. That boiler is cooling off the sodium to go back in, and it's taking the steam into the turbine to make power. Now this is only if you're trying to push even more power through the reactor to then, well, to get more fuel going. Because as you saw with that one, I got to the point where I didn't even push the temperature. That water at one point you can't push any higher. This you can push sodium a lot farther. Alright. Now we're gonna do some tests. The supercritical phase shifter, which I've already set up because this is actually a completely different day that I am editing this, and we'll go in depth of the byproducts and what they are actually used for besides just making antimatter. Make sure to check out that video, which will be down in the description. It has been posted, and we will see you all then.